Now let us solve some examples based on DFA. Now here is the first example. If you observe here, it is given like let DFA be. That means the DFA can be defined with the help of those 5 tuples, out of which here they provided the 4 tuples: Q, then sigma, Q naught and F. The values are already there in the problem statement itself, and the table is also given. The transition table is given in the problem statement itself. If you observe Q, which is the set of states, so we have 3 states, that is A, B, C. Q naught is initial state, so here in this case we have A as the initial state. Sigma is equal to 0, 1, that means we have 2 input symbols, zeros and ones, and F is the set of final states. Now here we have only one final state, that is C. Now this is the transition table. Now what we have to do is we have to draw DFA based on this transition table. Now if you observe, we have 3 states like A, B and C. With the help of this or this, you can say A is the initial state, which is represented with an arrow, and here it is represented with Q naught, and C is the final state. Here also it is represented with F is equal to C, so star represents the final state. So here we have the final state. Now if you observe by observing the table, we have to draw the transitions. Now if you observe for A, on input 0 is going to the same state, that is A. That means we have to represent a loop over here. For A on input 0 is going to the same state, A. So there is a loop for the state, so we have represented like this. Now state A on input 1, it is going to state B. A on input 1, it is going to state B. So this will be your next transition. Now go for state B. State B on input 0. State B on input 0. B on input 0 is going to state C. So this will be our next transition. Now next one, B on input 1 is going to state A. B on input 1, it is going to state A. So this will be our next transition. Now for state C. C on input 0. C on input 0, it is going to state B. And C on input 1. C on input 1, it is coming to the same state. So we have to represent it like this. That is in terms of loop. Now the next problem we have, draw the DFA for the language accepting strings ending with 0, 1. Now it is said that strings ending with 0, 1. Over input symbol said they said 0, 1. Now the first step, what we're going to do is we have to find out the number of states required for this. So whenever we have strings ending with, we're going to follow a formula for number of states is like n plus 1, where this n is the length of string, that is n is the length of substring given in problem statement. So if you observe the length of the substring given in the problem statement, that is 2. So 2 plus 1 will get 3. So we require 3 number of states. Now after this, what we have to do is, for second step, we have to find out, or we have to list out the strings which are there in the language which is accepting this condition, that is strings ending with 0, 1. So we can say 0, 1 is itself the string which is ending with 0, 1. Now we can have 0, 0, 1. We can have 1, 0, 1. We can have 1, 0, 1, 0, 1. We can have 1, 1, 0, 1. We can say 0, 0, 1, 0, 1. So like this we can have the strings inside this language. Now we are ready with the states, we are ready with the listing of the strings. Now we have to draw the DFA. So as it is said, we require 3 states. We are going to draw 3 states. Q naught is my initial state, then we require Q1 and Q2, which will be my final state. Now the substring which is given in the problem statement, provide the transitions for that string like this, that for the first symbol with 2 states, first 2 states, that is from Q0 to Q1 on 0 and Q1 to Q2 on input 1. So this will be my transition for the given substring, that is 0, 1. Now if you check the listing of all the strings which are acceptable over it, the listing is 0, 1. The first string is 0, 1. So we can see that it is acceptable over it. we are starting from the initial state and we are reaching to the final state. So we can say that 0 1 is acceptable over this finite automata. Now if you observe the next string, we have 0 0 1. Now if you observe for first state, that is q naught, we already have provided input for 0, so I cannot provide any other input for 0, because in DFA for any one symbol we have only one transition, so I cannot write for 0 again. So it is for sure कि I cannot have any transition on q naught again, as we already have provided over here. So there is a chance that I can provide it with q1, because for q1 we already have provided for 1, not for 0. So if I write a loop over here for 0, we'll get 0 0 1, which is completing our second string, or we can say this one is acceptable over it, or you can say 0 0 0 0 1. So any number of zeros followed by 1, it is accepting over it, so we will go with this transition. Now next one, next string we can say that 1 0 1. So for state q naught we already have provided for 0, there is no transition for 1, so I can have a loop over here for 1. So if I provide a loop over here for 1, we can say that 1 0 1 is acceptable over this. So we can say this one is also acceptable, this was acceptable, this one is also acceptable, and this is also acceptable. Now check for this one, 1 0 1, again we have 0 1. So if we have next input on q2 for 0, I can say that if I go with this way, we'll get 0 1. So we can say that 1 0 1 0 1. So we can provide the input of 0 on state q2. Now check for the next string, that is 1 1 0 1, 1 1 0 1. So we can say it is acceptable. Now check for next one, 0 0 1 0 1. Now whatever strings we have listed, we got all of the strings, or you can say they are acceptable over this finite automata, or you can say deterministic finite automata. Now last step is to check each state whether it is giving input for all the symbols or not. Now all the symbols, I can say here we have only two symbols, 0 and 1, so we have to check each state is giving input for both the symbols or not. So if you observe q naught is giving for 0, there is for 1, so no need to do anything. Check for q1, it is giving for 1, there is also for 0. Now go to q2, q2 is giving for 0 but not for 1. If suppose on state q2 the input 1 arises, so we can say that 0 1, again we have one more 1. So if 1 arises over here, or whatever DFA you have drawn, whatever the left whatever transitions are left, you just have to pass all those transitions to the initial state. So if I provide a transition like this, we can say that 1 0 1 1 0 1. So ultimately the string is ending with 0 1, so we can say that this one is acceptable.